Okay, so now the next step is we have understood the relevance of interfaces. In Hello World, we saw that the reason why we use an interface and we don't create a C Hello World is because if you use an interface, then you're able to replace one service with another, switch from one to the other very quickly. There was only one line of code that you had to change, and then even that, and then we use the factory. We could ensure with the interface that the greet function is common for both. So this would remain as is. And then we add one more line of code, which again we standardized by having a factory. The uh, uh, the code or where you write the name of the class will be encapsulated in the factory, and that's going to be the responsibility of the class owner. You've done that in the another shared library. I think you've written the factory code, and now we have this shared library which will provide the Hello World class as well as the factory. So the conclusion that we said is that every class provider should when he writes a class, he has to inherit it from an interface, and he should also be responsible for providing the factory, which is what is going to create the class for the client. Now, at this stage, what I would want you to do is switch from another shared library to my shared library. We'll come back to that C Hello World class. And in that, what we do is uh, we need to, if I come back and see what we are going to do, let's now start creating a class called as C Mobile. A mobile class, if you have to create. Now that you understood the concepts of interfaces and factory, we'll have to apply it in some real life where we have got a C Mobile class. And the initial uh, intention or the initial way you worked with any class is that you got a class, you create a class, and you write all the methods in it. Now, for a mobile, for example, there are methods like make call, receive call. A mobile could also be used as a calculator, so there could be add and subtract methods in it. And if you're not aware of interfaces, you would perhaps just put everything here in the mobile class itself. But now that you know that there are interfaces, you would say that there's going to be one iMobile and there's going to be iCalculator. Now, why is iCalculator there? Because before mobile, we had calculators which were invented, and somebody created an iCalculator interface, and calculator was dedicated to only calculating. So he had C calculator. So by the time you create a class called a C mobile, you have got interface iCalculator already there with add and subtract. And then so you'll have just mobile, iMobile, which will have its own methods like make call and receive call. So anytime you introduce a new class, you'll have to see what interfaces already exist. And if your class is going to implement it in its own way. So add and subtract, if you notice, the calculator is there in a mobile also. It may not be as powerful as a calculator, but it has got some implementation of it, right? So now add and subtract of iCalculator are now implemented both by C calculator in a much better way and C mobile in a mediocre way, I would say, because mobile is actually meant for make call and receive call. And that is what is called as implementation of add and subtract methods by different classes. And that is why you people would want to switch from one service to another. So a person has used a C mobile ad and he says that, okay, I'm not happy with the way ad is working. There are a few checks which are missing. Both of them add, but can I have the calculator add? Then you can replace the mobile with the calculator there. But overall, the intent is that now we have to create a C mobile, and for that, iMobile and iCalculator already there. So we see a few classes that you'll have to create now. So let's come back to the interfaces library, which you already have here, right? So we start with the interface library, and in that, I've got iMobile.h and iCalculator.h, two interfaces which have been created. Okay, so here's the calculator interface we have introduced. Pretty straightforward. Add and subtract are there. There's a virtual void interfaces. As you know, it's a pure abstract class. All the implementations, there won't be implementations equal to 0. And you know that every function in an interface will be virtual. Pure abstract class would have virtual functions in it. I put couts here. Going ahead, this will be useful for the constructor and for destructor. And that's it for iCalculator. We also have a CPP for it, which has nothing in it. Okay. Then you've got iMobile.h, which would be again make call and receive call. You take note of this naming convention for the methods. It's always called as camel case, because there's a hump here. The words are separated by this uppercase. You get to know why which word ends where, and make call and receive call. That again, we've got the mobile constructor and destructor. And when you do that, and when you compile this, I think this would get compiled, right? Let me again do it. Put a space there, save it, and recompile or rebuild it. Okay, so that's where the interface library got built. We'll go to the my shared library where okay, the my shared library will have C calculator in it. I'll start with C calculator.h, which is a class inherited from iCalculator. So there's a dependency on the interface here, as I see, iCalculator.h. Then you've got add and subtract here, and constructor destructor for calculator. Again, for mobile.h, most importantly, we have inherited it from both, as we saw, iMobile and iCalculator. So it would have the implementation of all four methods in it, again, constructor and destructor. So if I come to calculator.cpp, I've got add and subtract methods here, and I put a cout here so that I get to know which implementation is called. This is the calculator add and subtract. If I go to mobile CPP, I've got all the four methods in mobile: make call, receive call, add and subtract. And okay, and you have the mobile implementations of add, subtract here. Another point is about we would have to actually put the constructor destructor. I'll add those also here. So make it a point to add the call to constructor destructors for these classes also. I'll do that soon. Okay. And then the factory, if you notice, the factory has been enhanced here. We have got two more methods: create mobile object and create calculator object, which is again a static method which returns iMobile star and iCalculator star. So if I go back to your factory.cpp, you would see that it creates a mobile and it returns iMobile. And here you have got the calculator object, which creates the calculator and returns the calc. Okay, for the moment, it's returning iMobile. Okay, so the factory has been enhanced here. Another important point, the factory is dependent on interfaces we use from a different library and the class headers. Okay. One important change, if you notice here, that I don't really have to give the entire path of the interfaces. Normally, there's a way to do it. If I go to my shared library properties, you have this in C, C++ general, additional include directories. In this, I would be able to give the path of your interface libraries. That's where your interface headers will be found. So if you give it here, you don't really have to give the entire path here, right? So the factory is dependent on interfaces. The classes are also dependent on interfaces, if I see here. And again, you don't really have to give the entire path of it. So obviously, if the headers are there, then have the libraries will also follow. If I go to linker input, I would see that in the linker input, would have the libraries as which library is this dependent on? Interface library.lib. Yeah, that is to take care of the link errors. So yeah, we have the C mobile class here. And I think what I've done is I have declared in the inline. In fact, the constructors and destructors are inline for C mobile and C calculator. So you don't really have to do it again in the CPP. And that's the reason. So you don't really have to do the constructor destructor. They're already there. So that would actually, if I just again save it and check whether this compiles, I would rebuild it and I'll see that the shared library gets built here. Yes. And after the shared library, you've got the next as the console application here. So if I come to the console application, what changes will happen here? Let's open the CPP file. Okay, one thing is obviously I've added the calls to the factory method create mobile object where I get the mobile and then I make calls, receive call from it. One point that you would note that you won't be able to make a call to add and subtract because this, remember, it's not a pointer of C mobile. This time you're working with interfaces in your main. And so you've got a pointer here of iMobile. So iMobile is a sibling of iCalculator. So when you make calls here, you would get a compile error coming here. So if I just uncomment it, you would see that this results in a compile error which says that iMobile has no member at, right? So that is what would be your next challenge would be how do you retrieve the calculator pointer now from the mobile pointer, interface pointer, yeah, to address these compilers that we are getting. iMobile has no member add, iMobile has no member subtract, and so on. So that's going to be the class diagram, which would help you relate with it. Okay, and with that change, if I just run this, and what is the console application dependent on? At the very top, let's see hash include. I've done a mobile header. I've done a hash include of it, both the factory and mobile, which is needed. I wanted to make it clear that there's something called as forward declaration and hash include. You'll have to be very cautious. As far as possible, do a forward declaration. You know what a forward declaration is? That, okay, I don't really want to include the entire class, but only giving this would be enough. Now, in this case, it won't be enough. This is called as that, okay, I'm just forward declaring my class that if that happens. Now, I'll show you the case where forward declaration works. If you come back here to the cfactory.h, yeah, you'll notice that not this one. Okay, we'll have to go to shared library and go to, okay, be cautious. You know, cfactory was there in another shared library, but now we are not really any longer referring to another shared library. So I did that mistake of, you know, updating cfactory.cpp, but that remains the older one. We are not working with another shared library. We are working with my shared library where if I come back to cfactory.h, this is forward declaration. Okay. And you'll soon realize why it's important. Maybe going ahead, I'll show you. Not, you should not hash include as far as possible. So why this works here? Because if you notice here, it's just that a pointer is being returned, the declaration of it, for which forward declaration is enough that, you know, the compiler should only know that a class of iHelloWorld exists, which is what the forward declaration does. But if you go to cfactory.cpp, where you actually return this pointer, you do a new of C hello world, you get this API hello world. In this case, when you do a new of C mobile, you're able to you would have to hash include C mobile. If C mobile is hash included, then C mobile in turn will okay, then if I come back to C mobile.h, do I have to hash include iMobile? Yes, because you're inheriting from it. So C mobile includes iMobile and iCalculator. But C factory.cpp, if I take it here, has pi hello world coming in here and new C hello world. So if hello world and you've got the C mobile, C calculator included, and do you have C hello world included? We don't really need, I think, I hello world and PI mobile need not be I hello world, I mobile are not needed. Okay, though there is a reference to it here, it won't give any compile error. Hopefully, let's see that. I've saved it, and then if I again recompile this, this works, right? So the question is that if it's being returned and if it's being stored in the parent class pointer, since the child class hash inclusion was done, the parent class will also come in, right? Because the child class C mobile.h would make a hash include of your iMobile.h. But in the factory class, again, what you did was you just did a forward declaration, but in the factory CPP, you're doing a hash include of those things, right? And then when you go back to the main, we are including these two, cfactory.h and iMobile.h. Now, cfactory.h, if you notice, has the forward declaration of all the interface pointers. And that will not be enough here because you're actually making a call here, right? So for that, hash include of iMobile.h is needed. Then where is the class hello world? Okay. Because we did make calls to hello world here. So how did it compile? That's something that isn't. Did you had it here, right? Had it here. Now will it not compile? Let me just check now because had this. I think. Well, let me restore this one and check if it compiles. It won't because let's see. I hello world is not defined. It says yeah. So I hello world. What do? We can just do a hash include I hello world.h. That we can do it, and the factory anyway is there, and I hello world.h is there. So with this inclusion, I believe that we are able to rebuild it, and it succeeds. And now if I rerun it, whether it will run. Yeah, so you see this is how it should run. That high will be there uh, in iMobile constructor, in iCalculator constructor, in C mobile constructor, because you're creating a C mobile. So the base class will be called first. iMobile, iCalculator, and then C mobile, and then make call, receive call. And for the C mobile, the two calls, add and subtract, we have commented it because it would give a compiler. I'm just wondering where do we have the destructor of it? That's not being seen here. Okay. Yeah, so it's obvious that the destructor of mobile is not called because if you go to the cfactory.cpp, you'll see that it's created on heap. So you'll have to call a delete to actually delete or call the destructor of C mobile. And that's the reason the destructor is not called. We'll see that as we go ahead, who handles the delete of this. But that's the next step that you'll have to do. Follow this video and do this hands-on. Console application, again, the dependencies, I just go back here. In CC++, it would be for the include directories, we'll have to see what it is. General. Yeah, so in this case, I think it's dependent on interfaces and my shared library. For the interface headers, for the class headers, do we require the class headers here? Yeah, we would require it for the factory. And for the linker input, I would say for linker input, the libraries which are included are again interface library.lib and my shared library.lib. Yeah. So with that change, this works. Okay, so that's going to be your next assignment. And always remember this particular picture here, that what we did now. So far we have done this. This is the class diagram that we are going to do. And now the next step is to switch from iMobile to iCalculator.